Good afternoon. Welcome all to this 3 days online FDP on networking simulation using NetSim software organized by Dellsoft. Dellsoft is a software solution provider in education sector where we provide software solution to different departments like electronics and communication, electrical, computer science, IT, mechanical and civil engineering. So we conduct these kind of online sessions to do aware of latest technologies and related softwares to faculties and researchers. So in continuation of this, we have organized this 3 days online faculty development program on networking simulation using NetSim software. So on this first day, we will have an introduction of NetSim software. Then we design and analyze an Internetworks scenario. Then we will have a custom code, then implement it in NetSim, and the question answer would be discussed after the presentation. So you can write your question in your text box. So first question here is, why we require this kind of network simulator or NetSim? So on this side of slide, we can see there are some observations in networking domain is given, where we can see that our existing network traffic will be 4 times in next year, that is 2017, as per our use of mobiles, tablets and other handheld devices. We watch 2+ billion videos every day, which also constitutes heavy traffic on network. Further, more and more devices like mobiles and handheld devices are joining this network, forming a network of things network. So as an example, we can consider the case of recently launched Reliance Jio connections, where users are offered free voice calls and data. But you must have seen also in the news that Jio faces 2 crores call drops every day, as the traffic load created by Jio's free voice calls and data cannot be handled by other operators, as they are not ready with their infrastructures to cope up with this situation. So in having these observations, it leads researchers in this field to conduct research on these domains. These are mobile ad-hoc network, wireless sensor network, cognitive radio, LTE network and LTE advanced, then IoT, Internet of Things. And when we present our research paper in IEEE and ACM, there 50% of research paper requires a network simulator. So now overview of NetSim software. So NetSim is a scientific tool for designing and validating networks and protocols. So hence it has a lot of relevance in protocol research and development, and in defense it is used for simulating central network-centric warfare. So it has a wide range of technologies which is possible to simulate in NetSim. Our Internetworks, that is LAN, WAN and wireless LAN, mobile ad hoc network, WiMAX, cellular network which consists of GSM and CDMA, cognitive radio network, LTE, wireless sensor network and IoT. In NetSim standard version, users are provided with C source code of network protocols which are implemented based on IEEE and IETF standards. So the purpose of giving the C source code is to enable user to edit the standard protocol existing in the software and writing their own protocols, and they can link it with NetSim and analyze the performance of the newly designed protocols. NetSim 9.1 has been launched recently in August, so some features has been added to the existing version. So first is LTE Advanced, which has been added with carrier aggregation and multi-antenna techniques that is SU MIMO and MU MIMO, then relay nodes are also there. In MATLAB interfacing, new application of creating and simulating real-world communication parameters and then dynamic clustering in low-power wireless sensor network has been added to enhance the functioning of cluster heads in wireless sensor network scenario. Then in wireless network, a very popular and effective rate adaptation algorithm, Minstrel, has been added for an effective wireless communication in the network. In packet animation, detailed packet information has been added along with running the animation. Then a new technology, MANET, that is a vehicular ad hoc network, has been added, and it can be simulated using a third-party software that is called Sumo, Simulation of Urban Mobility, which is a open source tool which can be linked with NetSim, and it can be used for vehicular ad hoc network. Now NetSim has a huge number of customers varying from industries where it is used for network design and validation, to defense labs where it is used for network-centric warfare simulations, and it is used in R&D labs for protocol development and new technology testing. Many PhD research papers are published by utilizing this tool. Now in academics, NetSim is also having an academic version, and that can be used in network labs of undergraduate curriculum and in advanced network labs of graduate courses, and it has a standard version where it can be used for research purposes. This is the architecture of NetSim internal architecture, which provides a holistic view of NetSim, where users will design the network and configure it in a GUI interface, which will be simulated by NetSim engine and thereby provide multiple metrics regarding performance of the simulated network. User is not required to write any script or code while designing and configuring the network scenario. This is one of the striking features of NetSim. It's NetSim engine itself. As you can see, it is utilizing a virtual network stack, which actually mimics the real-world TCP/IP stack, and hence makes it very easy for any user to edit protocols and also get fairly accurate results. Now NetSim is divided into some modules or components where standard users can make a selective choice while using NetSim. So this is a list of contents of components and the corresponding IEEE and IETF standards referred during implementation. So for illustration, component 1 consists of protocols implemented in WAN, LAN and wireless LAN like Ethernet, IEEE 802.11, AB, GN, AC. Then component 1 is the base component, that is all other components require component 1 to run. Similarly, component 2 consists of network based on legacy network, that is Aloha, Pures and slotted, CSMSCD, token ring, token bus, ATM and frame relays, etc. Then component 3 consists of BGP network and this border gateway protocol, and component 4 contains advanced wireless network, that is having MANET and WiMAX, mobile ad hoc network and WiMAX. Then component 5 is GSM and CDMA, then cellular network. Then component 6 is having wireless sensor network and IoT Internet of Things and having ZigBee protocol. Then component 7 is cognitive radio network or wireless radio array network. and component 8 is having long-term evolution or long-term evolution advanced network, and these are their corresponding international standards available. So here in modeling and simulation, which is a scenario creation, so user can easily click and drop devices and configure them in GUI. They can also model multiple traffic of various types like FTTP, STTP, custom, constant bitrate, email, voice and video, among nodes, without even writing a single line of code or script. And we can start the NetSim by using a CMD line or XML based config files. So we usually prefer XML based config files because these are quicker understanding, better presentation, and it has an automatic format verification. Now NetSim provides distinct quantitative metrics at various abstraction levels such as network metrics, link metrics, TCP metrics, application metrics, protocol metrics, and device metrics. When we simulate it, after the simulation it shows this matrices. With the help of metrics, users can analyze the behavior of the model network and compare the impact of different algorithms on end-to-end behavior. So the network metrics allows user to view the values of the metrics obtained based on overall network. Then application metrics displays the various metrics based on the application running in the network scenario like throughput, delay, and many more. The link matrix displays the values of the matrix related to each link like packet transmitted, packet errored, then protocol matrix displays the protocol based metrics which are implemented in network scenario. Metrics will vary depending upon the type of network simulated. In this case, you can notice TCP metrics, IP metrics, and OSPF metrics. Then device metrics displays the device related metrics like ARP table, IP forwarding table. Then queue metric displays the value of the queue metrics for the devices containing buffer queue and like routers, access points. Then there is a packet animation which enables user to watch traffic flow through the network for in-depth visualization and analysis. Unlike other network simulators, which only shows the transmission of packet, NetSim goes a step further and displays some basic packet information like packet ID, type of packet, and whether it is successfully transmitted or not. Users can also observe the changing location of nodes due to inherent mobility. NetSim allows users to generate trace files which provide detailed packet information useful for performance validation, statistical analysis, and custom code debugging. So first is packet trace, which logs a set of chosen parameters for every packet as it flows through the network, such as arrival times, queuing times, departure times, payload, overhead, errors, collision, etc. And now the event trace. As the NetSim is a discrete event simulator, the event trace records every single event along with associated information such as timestamp, event ID, event type, and more in a text file or .csv file, which can be stored at a user-defined location. Now dynamic metrics. Dynamic metrics allows user to monitor the value of a parameter over simulation time. So this is essential for researcher to understand the behavior of a network at any instant of time. So as of NetSim, this version, link throughput, application throughput, and TCP congestion graph can be dynamically plotted, and these plots can be done offline or during the simulation. So now writing custom code in NetSim. So as the NetSim has two versions, one is academic and one is standard. In academic, you can design and analyze your network through GUI, and in standard version, you can edit the codes, existing codes, and you can create your own codes also. So on this slide, we have tried to answer the question asked by many people usually, that how this software is different from open source software available freely on internet like NS2 and NS3. So as we know, we have to write a lot of programming while using any open source tool for creating and simulating our network design. So users spend 80% of their time understanding the simulator and its language. And sometimes some people fight with its installation procedure that creates a very hassle using it. So considering these difficulties, NetSim has been designed with its GUI feature along with custom code editing, where we can design and analyze our network in GUI, and if we wish to change existing protocol or create our new protocol, that can be done using Microsoft Visual Studio 2010 version, where we can save our files in DLL extension and link it with NetSim GUI. Now NetSim has interface with MATLAB software, where we can use some functions given in it related to network technologies by calling those functions in programming using Visual Studio. So when we save those DLLs and link it with NetSim, we can use MATLAB functionalities. And it has also interface with Wireshark. You can enable the Wireshark in the design, and while running the simulation, the Wireshark is active. As you know, Wireshark is a free and open source packet analyzer. It is used for network troubleshooting, analysis, software and communication protocol development. In NetSim, instead of performing some mathematical calculation and providing the user to the user, it actually generates the packets and transmits it within the simulated network. Hence, Wireshark can be used inside NetSim to capture these packets at multiple node locations and perform further analysis. Then this IoT feature is also added in the 9th version only. So here in IoT, we have modified wireless sensor network, where sync node is replaced by low-PAN gateway, which receives the data from sensor and sends further to other networks. in host server where we want to store our data. You can see in the screenshot the scenario is created there. In the screenshot we can see various devices are used to receive data in low-PAN gateway, which further store it in other hosts. So apart from sensor and low-PAN gateway, we have to use inter-network devices like routers, switches, access point, and host. Data link and physical layer are configured as IEEE 802.15.4. A network layer can run both on IPv4 and IPv6 protocol. Its routing is done via AODV, OLSR, and ZRP. These are inputs that can be implemented here, and these are the outputs we can get. This beacon order, superframe order, backoff exponent, power consumption, these are the inputs. And that output is routing overhead, delay, power consumption, these are the outputs. And their C source code are also available in standard version for modification. Now NetSim Emulator. Network Emulator is an add-on module which enables you to run the live application in real time with various network conditions like error, delay, and loss. So in the screenshot we can understand a scenario where we have created an emulated network where we are sending a video traffic from a real simulation PC client to other client. Where we can see in the output we are getting our video with some distortion. That is due to delay and losses we face in the network during packet transfer. So these kind of real application can be used to analyze in emulation module. It can be used for network design and validation of military radios, SCADA, metro rails, and for performance testing of new application and protocols. And its benefits are it can emulate a wide range of technologies like switching, routing, MANET, cognitive radio network, 4G LTE, Zigbee networks, and it is cost-effective alternative to hardware emulator as it is purely virtual. So it can be used to analyze without any complicated configuration that require in hardware emulators. And these are the research areas that you can do the analysis on cognitive radio network, IoT, MANET, and wireless sensor network. So for the research, reducing the learning curve, the time and effort of protocol developers, NetSim provides APIs which can be reused to perform activities like packet creation, deletion, IP address comparison, and many more. So a manual is provided with the software to assist the researcher and developer for editing the source code. And these are our 300 plus customers across 15 countries. Right from the industries and education. So now we will go to the software part, where so this is the software. So this is the first window we will opening the software. So for simulating any network, we go to the simulation and click on new. So we will be having these technologies that are given in NetSim. So first is Internetworks, where we can design and analyze wired and wireless network. Then in legacy network, we have pure Aloha, slotted, token ring, token bus, CSMA CD. Then in advanced wireless network, we have MANET, VANET, and WiMAX. And BGP network, cellular network, we have GSM and CDMA. Then wireless sensor network, Internet of Things, IoT, Zigbee network, cognitive radio network, and LTE and LTE advanced networks. So whichever technology we select, we can design and analyze those networks. So we just today we select the Internetworks. So this is an environment where you can drag and drop these devices and connect them. And here we can see the devices are enabled here, and some of the devices are disabled. As these are related to different technologies, they are disabled here. In the nodes also, there are some nodes are enabled, some disabled. So here we can design and analyze wired and wireless network. So we are given with wired node and wireless node. So we just select the wired node. Let's see, we have dropped two wired nodes and we connect them with a switch. And further it is connected through a router. Okay. This is your wired network, and if you want to connect a wireless network along with it, you have to connect an access point. Okay. So we can connect these devices through wired link. We just simply have to click on the source and destination, and we can link it the connections. So this is your wired network, and for wireless network we have to connect the wireless devices. So we just connect the wireless devices. And for wireless link we can connect these devices. Now we have created the network, the wired network and wireless network. So for seeing the properties of these nodes, we just right click and click on properties. We can see the properties related to this node only. So where first is global properties, where device name is first is given device name, device type, its location, and here we can enable or disable the Wireshark. When you click on online, the Wireshark is enabled. So if you click on online, Wireshark is enabled. So let's enable this Wireshark on this node 1. Accept it. Likewise, we can see the properties of switches, which is having global properties. Then it has three interface of Ethernet of three interface because it is connected to three devices here. So in first interface we are having data link layer, physical layer properties, where it has having the switch properties like switch ID, switch priority, switching latency, buffer size, and switching mode and speed. So there are a lot of parameters involved in the simulation. So if anybody doesn't know about these parameters, so he can click on this information tabs given here. So if you click on this I tab, you can see the parameters with their informations like switching mode, like speed, like STP cost. So we can see this information if we don't know about these parameters. So these properties are common in all the nodes. This is the interface of wired node, where you can give the IP address, subnet mask, and default gateways. Okay, data link layer and physical layer are made constant. Then in network layer, IPv4 protocol is given there. Then in transport layer, TCP and UDP protocol are given there. There are various parameters like congestion control algorithm, window sizing, MSS. All these are given. Application layer is defined outside this box, so you can see. Then in router, you can see the common properties. You can enable the Wireshark on the router also. In transport layer, having the same parameter. Then in network layer, we are having the IPv4 protocol. In network layer, we can also define a firewall. So if we enable this firewall, we can restrict any path. If we want to block any path and want that this path should not send the traffic, we can block this path through this enabling this firewall. Okay. Then access point parameters. So it is having both interface of Ethernet and wireless. So it has having both the parameters. So for wireless, there are different properties are given in data link layer. The IEEE standard, rate adaptation, you can enable or disable. Retry limit, RTS threshold. Then in physical layer, you can define the standards of IEEE, ABG and AC. Transmitter power, frequency band, okay, ED threshold, and standard channels you can define. Like the nodes, we can see the properties of links also. This is wide link, where link type is given there, point to point, link medium, link mode, full duplex, and maximum speed, uplink and downlink, uplink BR and downlink BER. Then uplink propagation delay, downlink propagation delay. Then wireless link, we can see the properties, link type, link medium and link mode. Then in channel characteristic, we can define these 4 types of channel characteristic: fading and shadowing, fading only, line of sight, and no path loss. So currently I am setting it as no path loss and accept it. So after configuring the network, we can configure a traffic among these network. So we set this application tab here and right click and click on the properties. So we can see in application type, we can send these type of application on our network like constant bitrate, custom, email, HTTP, video, voice, all kind of application are there. So let's say we configure a custom type of application from source 1 to destination ID 6. This is your node 1, this is your node 6. So we are sending one application of custom type from 1 to 6. And if you want to add one more application, let's say from node 2 to node 7, so we can add one more application. Let's say we can add same custom type of application from 2 to 7. So now we are having the 2 applications. So we can accept it and see one line connecting from node 1 to 6 and node 2 to 7. Okay, so we have configured this network now, and I have shown you in the presentation that these features about packet trace, event trace, and dynamic metrics. So we can enable these features to see the in-depth analysis of packets, events, and the graphs. So in packet trace, when we click, it has a file name, file type, and these are the attributes given which will be created after the simulation. We just have to click on OK. In the event trace also, these are the attributes: ARP, fast Ethernet, RIP, TCP. All the attributes are given there. You just have to click on OK. Then in dynamic metrics, link metrics, application metrics, and congestion window, we can see this graph. And we have the option of plot graph after simulation and plot graph during the simulation. So we select the plot graph after simulation because during the simulation, our simulation will slow down. So we just select OK and run our simulation. So here also we can choose record animation, play and record both, or don't play or record. So we have to see the animation, so we'll record it. Click on OK. So as we have enabled the Wireshark, that will run during the simulation. So here we can see the TCP packets are being captured here during the simulation. The Wireshark, it is capturing the real-time packets running in the simulation. And our simulation is running. So now simulation is over. And as I've shown in the presentation that it creates a performance matrix after the simulation, where first of all network matrix is given, where simulation time is given, packet transmitted, packet errored, packet collided, bytes transmitted. You can click and read about this result given here. So this is the result of overall network. Also you can see the link matrix. Where you can see the result according to the links given in the network, link 1 to 5. These are the packet transmitted, errored packet collided, bytes transmitted, payload transmitted, and overhead transmitted. Okay. Then queue matrix, TCP matrix, IP forwarding table, okay, and OSPF matrix. So this is your application matrix, where we have added 2 applications of custom type from 1 to 6 and 2 to 7. So it is showing the result, packet transmitted and received, and this is our overall throughput in Mbps. So if you want to create the overall throughput of network, we can add this 2 applications. Also we have added a dynamic matrix, so we can see the graph of link throughput and application throughput. So in links, link 1, 2, 3, 4 and 5, all these are given. Then in application throughput, 2 applications we have added, custom and application 2 also custom. Then TCP congestion window of both the applications. Okay. Then we can see the animation, packet animation. When we click on packet animation, we'll see how our packets move from 1 to 6 and 2 to 7, and also their detailed packet information given in this console window. So we can see the packets moving. First it will show the signal, and when it got the acknowledgement, it will send the custom packets. So as the path is same for both the channels, so one by one it will send the packets and acknowledgements. So it is showing the packets in the animation and also in the text format. So we can stop the simulation and go for further analysis. Now we have added packet trace and event trace. So we can open the packet trace. Here we can see the each and every packet information given here. So for analyzing these packets, we can just use features of Excel. So freeze top row and make it a filter. Then let's say we analyze packet 1. So these are the packet number 1 given here. So which are having custom type we have added, and the packets to packets information is given there. What path it is following: node 1 to 6, node 1 to switch 3, and node 1 to 6, then switch 3 to switch router 4. Their actual path where it has flown. Their the IP addresses, their successful transmission or not. I mean, any information related to packets is given in this packet trace file. So likewise, we can analyze each and every packet. There are 4,999 packets given here. So we can analyze one by one which packet we require. Okay. Likewise, we have event trace. So like packet trace, event trace also record the each and every event performing in the network. Okay. So these are the events performing in the network. Okay, event type, event time, device type, device ID, okay, protocols performing. So all the information about the events are given here in event trace. Apart from this, we can export our hold the data of the result in MS Excel format, where you can create the graphs. If we select, you can insert the graphs for any of the formats. Okay. So apart from dynamic metrics, we can analyze the result through the Excel format. Okay. We can analyze our result. Now, apart from this, it has one more feature of NetSim Analytics. Okay. So when we click on NetSim Analytics, here we can browse the metrics which are formed after the simulation. Let's say for first experiment, we have metrics.txt file we have added. Then metrics 2. Okay. I'm adding more than 3 networks. So let's say I've selected 4 metrics. Okay. Now we can compare this same matrix. It is related to Internetworks only, but it will vary a result according to its parameters like simulation timing, packet transmitted, packet errored, packets collided, bytes transmitted, payload transmitted, and overhead transmitted. Okay, so we can compare a similar network having different parameters on this NetSim Analytics tool. So this is all about working on NetSim GUI, where you can design and analyze your network through GUI. But if you want to edit any protocol, existing protocol, or create your own protocol that has some different procedures. So I'll just show you a brief explanation of how we can use the custom code in NetSim. So for that, we have to go to the installation directory of NetSim, see program files and NetSim standard, where we are having these files bin, docs, and src. So in bin folder, all the protocols which are given in NetSim are here with their DLL extension files, because NetSim reads their DLL extension only. So if we want to create or edit our protocol, we have to save it in DLL extension only. Okay. So in src folder, there is a simulation. We have made a copy of the simulation so that our existing protocol does not affect. So we have to click on this NetSim solution file, netsim.sln. So when we click, all the protocols will open in this Microsoft Visual Studio. All the protocols, AODV, ERP, cellular, cognitive radio, DSR, all is available here. So we have just edited a DSR protocol in dsr.c, and this is DSR protocols program. So we have just added a command of hello world, fprintf hello world in this DSR. So when we create its DLL and link it with NetSim and call this DSR function, DSR protocol, this will print first hello world, then when we put enter, and it will run the simulation. So we have to build this by just clicking on build, and we'll have a DLL file in DLL folder, libdsr.dll. Okay. So we have to copy this libdsr.dll in the bin folder of the NetSim libdsr. So we are having libdsr.dll already here. This is the original DLL. So we rename it to some default file so that our original DLL does not affect, and we copy our edited DLL here. Now this libdsr.dll is our edited DLL of DSR. So now if we create any, let's say, wireless sensor network scenario, which is having a DSR protocol running. So we just run a simulation. So we can see in the console window that hello world is printed first, because we have edited the protocol. So first it will call our hello world print command, then it will run when we put the enter. Okay. Here also, so it will show detected a change in libdsr.dll. So this message is shown here. So when we put enter, it will run further. So now we can analyze the result as usual. So this is just to show how we can edit our existing protocol and link it with NetSim to show how it will change. So here in Wireshark also there are some features given here. These are the TCP packets captured. So we can go to the statistics and click on some IO graphs given here. Okay, can show some IO graph. Then some conversation. We click on graph, it will show graph, time sequence graph, RTT round trip time graph, then throughput graph, window scaling graph. So these are the features of Wireshark which we can use for analysis. And here we can search any TCP packets we want to search. Okay. Then this is about simulation. Now we have some programming exercises also given in NetSim, where some protocols are given like ARP, cryptography, DVR, dynamic host configuration. Okay. All these things are given. Let's say for cryptography, we choose substitution, where a set of program is running in backend for encryption. So when we write, let's say, NetSim and a key text of 4 and run it, it will first show a plain text, and having key value of 4, it will create a ciphertext. And when we run the decryption, it will convert our ciphertext to plain text. So it has having the programming running in the backend that we can see. Let's first do the decryption part, where it will convert from ciphertext to plain text. Okay. Now we can see its interface source code running in the backend. This is your encryption program. You can change it according to our requirement. And here we have to save it in exe format, because here if you click on this user, it will ask you a exe or jar file. So you can save it in the exe file. You can browse this file from here, and when you click your file, it will run according to the addition you have made in the program. Okay. So now I'm done with my presentation. If you have any query, you can ask me by writing your question in the text box. There is a question of cost of NetSim. So we'll send you the details on your mail for the costing.